Hello, and I want to welcome you to a discussion on exponential and logarithmic equations. Okay, so let's get started. So for these kind of examples, not all exponential expressions can be solved using the methods where you have to break down bases. As you can see, 3 to the x power equals 14. 14 can be broken down to a base of 3. So we had to use other ways. Examples: solve the exponential equations by expressing each side as a power of the same base, then equating exponents. So for number 1, we have 4 to a power of x equals 64. So for this, what you want to do is say that 64, written as a base of 4, is actually 3, because 4 to the third power is equal to 64. And since, in this case, our bases of 4 are the same, we can just bring our exponents down, say that x is equal to 3. With number 2, we can note that 1296 is actually a multiple of 6, and when you raise 6 to the 4th power, that's actually what you get. So, and on the other side, 6 to the power of 2x minus 6 we now have the same base of 6, so we can bring our exponents down and solve for the variable. Excuse me just a second. Okay, so now we can set our bases equal to each other, or exponents, excuse me, since the bases are the same. So we can bring the 2x minus 6 down equals 4, the other exponent. Now let's solve for the variable x. So let's subtract 6 on both sides. And when we do that, oh, excuse me, there was a little mistake. Okay, this was a 2x minus 6, so let's add 6 to both sides. So we're going to have 2x is equal to 4 plus 6 is 10. So carry it on up here, 2x equals 10. Let's solve for the variable x by dividing both sides by 2. So x equals 10 divided by 2, or just 5. X is equal to 5. On number 3, we have 64 to the x power equals 2. Well, 2 can't be broken down any farther, so it's just a power of 1. While 2 raised to the 6th power is actually 64. So we can just multiply that power of 6 times the x. So now let's bring down our power. 6 times x equals 1. Since our bases are the same, let's go ahead and divide both sides by 6 to get the variable alone. So now we just have x equals 1/6. And finally, for a problem that looks a bit more intense, but really it's not that bad, 25 to the power of 2 times 2x plus 3 equals 5 to the power of 3x plus 10, or 3 times the quantity x plus 10. First thing I would want to do is say 25, and then I'd actually take the 2 and distribute it across. So 2 times 2x is 4x, and then 2x times positive 3 is going to give you a positive 6. And then just rewrite the other side. So now we can rewrite the same bases. 25 can actually be written with a base of 5, and it's 25 is 5 to the 2nd power. So just take that 2 we have and multiply it just by the quantity we already had of 4x plus 6, and then we just have our 5 to the 3rd times the quantity x plus 10. Well, since we now have similar bases, we can bring our exponents down of 2 times the quantity 4x plus 6 equals 3 times the quantity 10x plus 10. So, what I would do is go through and distribute 2 times 4x plus 2 times 6 equals 3 times x plus 3 times 10. Let's go through and simplify. 2 times 4x is going to give you 8x, plus 2 times 6 is going to be positive 12. 3 times x is 3x, and then we have 3 times 10 is going to just be a positive 30. So let's get all the x's on one side by subtracting 3x on both sides of the equation. So it's going to give you 5x plus 12 equals 30. Now let's subtract 12 on both sides of the equation. So we have 5x equals 30 minus 12, which is 18. Now let's get x by itself by dividing both sides by 5. And you're not going to get a very pretty answer, but you get 12 equals 18 divided by 5. Okay, if we now look at using logarithms to solve exponential equations, we have these procedures that we should follow. And now let's get our hands dirty and look at these examples. This time we're going to solve the exponential equation, express the solution in terms of natural logarithms, then use a calculator to obtain a decimal approximation for the solution. So we have, for number 1, 10 to the power of x equals 5.92. To start getting stuff away, we note that our variable is in the power, and the way to get the variable out of the power is to use the power of ln on both sides. So if we ln both sides, natural log both sides, that power of x is going to move to the outside now because of our properties of logs. So now we have x times natural log of 10 equals ln 0.92, 5.92. Now you get x by itself, divide both sides by natural log of 10. Extend the page. So now we have x equals ln of 5.92 divided by ln of 10. Now that's the terms in natural logs. Now if you actually punch that in the calculator, you should get x is equal to 0.772. Okay, with number 2, we have e to the power of x equals 10.1. So let's go ahead and use the same procedure of using the ln function on both sides. So it's ln. Okay, and then we note that our exponent power or variable will come out on the outside. So we have x ln e equals ln 10.9. Well, note that this ln has a power of e. So these are just going to leave to 1, or you can say cancel out. So x equals ln of 10.9. And that's in terms of natural log. But if you were to punch that in a calculator, you should get x is equal to 2.389. Now let's look at this last example from this section. We have 2 to the power of x plus 4 equals 24. Note that we can't get 24 with a base of 2 to some power, so we have to use our ln function. So let's ln both sides. Our power of x plus 4 is going to come out in front. And let's go ahead and keep it in parentheses. So we're going to have x plus 4 in parentheses times ln2 equals ln24. So let's go ahead and divide both sides by ln2 to get stuff away from the variable. So we have x plus 4 now equals ln24 divided by ln2. Now, to get x totally by itself, let's subtract 4 on both sides, leaving you with x equals ln of 24 over ln of 2 minus 4. And now if you were to punch that in your calculator, you would get that x is equal to 0.585. Okay, for our last topic of this video, let's talk about these examples. So we solve the following logarithmic equations. Be sure to reject any values that of x is not the domain of the original logarithm expression. Give the exact answer. So for number 1 have log base of 6, x equals 3. So we just take our base of 6 with our power that it equals 3 equals x. Now we're just simply solving 6 to the third power, which equals 216 equals x. Now with number 2 we have ln x equals 18. Alrighty, for this you want to say you have e, the power that we're equal to, because remember our ln has a base of e, then our power of 18, because that's what it's equal to, equals x. And that's all you have to say. For number 3, we want to know some of our properties we have, but for now we know that we have our base of 3, and what it's equal to is our power, in this case is 2, and now we're going to set equal to the stuff beside the base, which is x plus 10. So now we have a simple equation to solve, so 3 squared is 9 equals x plus 10. Let's solve for x by subtracting 10 on both sides. So 9 minus 10 is negative 1 equals x. And that is a solution. Okay, now for this final example, we have log, and we have a base of 10 that we just have to accept with x minus 3 equals log x plus log 4. Okay, so what I would say is that, let's bring this left side of the equation down of log x minus 3. Now let's use our rules and properties from before, and since we have the same base, or the same log, and the same base of unspoken 10, we can bring the x and the 4 together through multiplication. So we're just going to have log x minus 3 equals log of 4x. So now that our bases are the same, let's just go ahead and bring the other stuff down. When we do that, we have x minus 3 equals x4, or 4x, excuse me. Now let's subtract x on both sides of the equation to get stuff away from the variables. So now we're left with negative 3 equals 4x minus x, or just 3x. When we divide both sides by 3 to get stuff away from x, we have x is equal to negative 1.